Hello and welcome to NOS 2020. Thank you for joining us today. I am Melissa from the New York City chapter of PyLadies. Our group organizes events to share knowledge in the usage of Python while encouraging women to become active participants and leaders in the Python open source community. I'd like to introduce our next speakers. Johannes Unterstein, who works on Grass containers and other fun at Neo4j, and Julien Grobbelaar, a site reliability engineer for Neo4j Aura, will be presenting site reliability engineering at Neo4j Aura. Johannes organizes the Java user group in his hometown, Kessel, teaches Java at the DHBW Stuttgart, and works as a software engineer at Neo4j. He spent the last few years building distributed and containerized systems with a focus on orchestration frameworks. Currently, he is working on the managed Neo4j cloud product to enable users to enjoy graphs without worrying about their operations. Julien studied engineering at Stellenbosch in the Western Cape in South Africa, where he also managed to inspect several vineyards during his residency there. After university, he moved to London and spent 10 years at Cisco Systems working on and implementing a range of networking protocols and security features which power today's internet. For the last 3 years, he has been busy building Neo4j Aura and heads up the site reliability team to ensure the lights always stay on. Thank you and welcome Johannes and Julien.
Thank you and welcome to Notes 2020 and our talk, Site Reliability Engineering at Neo4j Aura. Neo4j Aura is our Neo4j as a service, graph database as a service offering. And before we jump into the SRE part of Neo4j Aura, I'd like to introduce ourselves. So I'm here with my lovely colleague, Julien. Julien is leading the site reliability engineering team here at Neo4j. So he's a great person to give you an overview about all the stuff we're doing here. And I'm Johannes. I'm also working in the Aura team. And the related part is dealing with the orchestrational bits of orchestrating Neo4j databases. And but those two topics are really related to each other. So this is why I'm here introducing you to this topic. But before we jump into Neo4j Aura, I'd like to take a moment to recap some of our use cases for Neo4j. So you've probably heard of the Panama Papers, where there was the big leak of millions of documents, and all those documents were given to journalists. And the journalists did what every sane journalist would do. They would try to put all the data into an Excel sheet. But since there was like a couple of millions of documents and those were highly connected data, that turned out to be a non-scaling thing for them, because they wanted to identify patterns in those leaked documents to find people cheating on the tax system. So they ended up using Neo4j for it. Or another use case, which is more in a medical aspect. So they are a research group using Neo4j to try to find the cure for cancer. And what they're doing is they're putting patient data into Neo4j and enhancing those data by characteristics of the cancer or the medication that their patients are getting and the treatment they're getting. And they're trying to also find a pattern of things that work well for a certain kind of patients. Or let's take the NASA as another example for us. And the NASA is putting all their engineering data worth of 30 years of engineering projects, and they put it in Neo4j, and they are building a knowledge graph. And what they're trying to learn is how the projects went and how they can learn from previous projects to accelerate the current research they're doing, where they try to bring people to the Mars. So now you could argue, Johannes, you showed us very fancy examples of usage for Neo4j, but we also have very enterprisey features or enterprisey use cases. For example, graph-based recommendation or graph-based searches or fraud detection. Whereas let's take credit card fraud detection. This is also highly pattern-based, where you in real time search the graph and you add a new transaction to the graph, and then you do pattern matching. And if this transaction falls into a fraud likely pattern, you would be alerted. So having all that said and coming back to Neo4j Aura, let's think about what all those people have in common. So all those people, the journalists, the NASA, the doctors, and the enterprises, all have in common that they put their mission critical data in Neo4j, but it's not their core business to operate Neo4j and keep Neo4j available 24/7. And also it's not their core business to repair Neo4j if it has a problem. However, this is where Neo4j Aura comes into the game. So as I said, Neo4j Aura is our Neo4j as a service offering. So if you're now watching and thinking, I don't want to deal with operating a database at all, you can go to neo4j.io, you could sign in, stick in your credit card, choose a region where you want to start your database. And the software we wrote would take care of operating your databases, starting your databases, making backups, healing it in case there's a failure, and so on and so on. So you would get rid of all the operational aspects while enjoying Neo4j, basically. But when we're talking about 24/7 availability, or something that is coming really close to 24/7 availability, we're always talking about clusters. So Neo4j has a clustering technology. It's called the causal clustering, and it's an implementation of Raft. So Raft has a leader-follower concept, which means whenever you want to do a writing transaction, you will need to go to the leading node. Whereas when you want to do a reading transaction, you can go to any of the nodes. And Raft works the way that when I, as a client, go to Neo4j and want to submit a writing transaction, then the leader would go out to the followers and then would also ask for committing that transaction. And when the leader got the majority of acknowledges of that transaction back, the leader would mark the whole transaction as committed and would give that back to the client. So the majority in a cluster of 3 nodes, the majority is 2. So you see here, we can afford to lose 1 node. So we can afford failure all of a sudden, and this will bring up quite a long way when we're talking about high availability. So let's talk about the terms that are on the bottom of that slide, availability. Availability in our terms means that the database is performing requests and can read and write and perform read and write transactions. So we have the 2 nodes running at a time, and at least 2 nodes are working properly. However, fault tolerance is the state where we have 3 nodes running and operating normally so that we can afford failure. So there's the 2 terms, availability and fault tolerance. Julien will iterate over those 2 definitions a bit later and use it when we're talking about metrics and so on. But as a last thing that I would like to introduce is our Neo4j operator. So when I was just earlier talking about when you go to Neo4j.io and say, I want to create a database, when you press the button, you expect a database to be started in the region that you selected. But so it's not me or Julien or someone else from the team that is then going in and starting a database on your behalf. We wrote a program to do so. So we call it the operator. So we're using Kubernetes for all our deployments as our deployment platform. And the operator is also a program living in Kubernetes. And when the operator recognizes the database that you just started in the database storage, the operator would go ahead and would compare your request of a starting database to the actual running system, the actual running databases that are already existing in Kubernetes. And if it's just a new database, the operator would see, oh, that's nice, that's a new one. So I need to take care of set up a new database, find a place to start 3 instances for the Raft cluster and set up a nice DNS name for you and prepare backups for you and all the stuff that are related to operating a full-fledged Neo4j causal cluster. So the operator is taking care of orchestrating the databases and keeping the databases alive and happy. So the operator is taking care of keeping the lights on of the databases. But in order to run the full Neo4j Aura system, we need way more things to happen in order to keep the lights on. And the answer to that is site reliability engineering. And this is the point where I would like to hand over to Julien to give us a walk through some of the aspects, what that actually means.
Thank you, Johannes. Hello, everybody. My name is Julien, and as mentioned, I'm the team lead for site reliability engineering here at Aura. And so here I'll explain a little bit of what that means. But first, we need to establish why we need an SRE team in the first place. So let's take a step back and start with our main goal. We want happy customers, which roughly translates to customers with happy databases. So what does a happy database look like then? In order to tell if a database is happy, we need to put instrumentation in place so we can easily answer questions like, is the database reachable from the outside world? Is the database itself online and available? Are transactions able to execute normally? Do we have an up-to-date backup? Is the database fault tolerant? To answer these questions, we need to start talking about collecting metrics. To get an overview of the database health, we simply measure everything, collect everything, right? So where do these metrics come from? Well, they can come from many sources. They could come from the infrastructure, things like CPU, memory, and disk usage. These are best collected from the VMs themselves, as that's where those resources are managed. The database itself has got its own metrics, for instance, transaction rates and rollbacks, as well as who the current cluster leader is. And finally, we also get metrics from Aura monitoring agents. These monitoring agents are workloads created by SRE engineers. They run in the environment and they look for interesting events in the dark corners of the system. Examples would be counting and sampling error rates in the logs, or computing percentiles over other sets of metrics. Good, so now we've identified the type of metrics we are interested in and how to get them. So now we're able to spot happy customers, right? Okay, well, let's take a look at a dashboard with some of these interesting metrics. Whoops, we've collected too many metrics and too many charts to show them all. I don't expect you to be able to read this page. I had to zoom out several times to show all 35 charts on one slide, but even this busy dashboard shows only a fraction of all the metrics that we collect. And these actually have been handpicked by SREs over time. So if we zoom in a little, we can see some of the usual suspects emerge: CPU and persistent disk usage, and of course, what database the customer has provisioned. As you can see here, some are 1 gig, some are 4 gig, and so on. So this is all very interesting, but looking at these 35 charts, can we tell which databases are the happy ones? Or more importantly, which ones are the sad ones? We need something else. SLIs. SLIs can come in many forms, but typically correspond to something that is important to the end user. They need to be well-defined and high-quality signals because they are ultimately the ones that will feed into our alerting system. Common examples would include latency. How long did the system take to respond to a request? Or an error rate of how many of all your requests that you've submitted to the system, how many succeeded? Contrast this to a metric showing high CPU, for example. If there's a high CPU usage on one of the 3 cluster members, but the cluster is otherwise healthy and queries are being executed normally, are we going to bother waking somebody up to take a look? No. Here I'm showing another dashboard which contains one of the most critical SLIs for SRE. Let's focus on availability for a moment, which is arguably the most critical of the critical SLIs. What does availability even mean at Aura, and how do we measure it? To answer this question, we have to hark back to the operator mentioned earlier by Johannes. It is already in the business of collecting all the database state and health checks because it needs this information to form a view about the database cluster's health. This is so that it can decide if something needs healing or updating. On every reconciliation loop, a composite metric is computed and stored by the operator on the Kubernetes resource, which represents the database. The composition of this availability metric includes things like, is the database healthy and has a leader? It has its bold port open, is able to receive cipher queries, is the DNS entry in place, and is reachable by its public IP address. If all these conditions are true, we consider this database to be available. Aura monitoring agents can then asynchronously scrape these metrics, sample them, and finally send them to the monitoring system, where we can create colorful charts. On the top right, we can see the availability SLI for it on the database level. We plot these to a logarithmic scale so that we can see one database not dominate the whole chart, which is exactly what's happened on the left-hand side if you see the large spike from a database that was unavailable for about 80 minutes. The left-hand side is more interesting to us as it shows our percentiles. P100 is shown in yellow here. This means a single unavailable database will start moving the needle, but we need to alert at scale, as we have hundreds of databases and hopefully thousands in the future. So it's the other percentiles that we must rely on. We can see the others in different colors. We have P99, which means 1% of databases are unavailable, P95 for not 5% of databases, all the way down to P50, which means half our databases are currently down, and we have a serious widespread problem. The takeaway here is that we can now very easily assess the scale of an outage and use this information to drive our SLOs. SLI, SLO, SL what? We've just touched on the SLIs and mentioned the word SLO, but let's take a step back first. Really what most people would be familiar with is the term SLA. The SLA is the service level agreement between the provider and their customers. This is the contract where the customer signs on the dotted line after, of course, reviewing all the T's and C's and sets out what will happen if the SLA is not met. Normally this is resolved by some credit or a refund, but it certainly means an unhappy customer. Once we've breached the SLA, we're in a really bad place because this is now too late for us to do anything to address the problem. This is where the SLO or service level objectives come in. We can define the SLO to be a reasonable expectation of the system and is agreed by SRE engineers and product managers. Product managers want to launch fancy new features, while SREs want to have a really stable system. So the SLO is a really handy tool to gauge what level of risk we are willing to take. But one thing we definitely want to do is set the SLO alert to trigger before the SLA has been breached, so that we have time to respond. So what does an SLO look like? Now that we've gone over some of the SLIs, we recognize the need not to breach our customers' SLAs. Let's focus a bit on an SLO. Here we can see a nice green SLO, meaning that the SLO is currently performing better than its target. We can see that the target for this SLO is set to 3.5 nines, that's 99.95% uptime, and we're actually delivering 99.8. Good, but what does this all mean? Well, 3.5 nines in terms of unavailability translates to less than 21 minutes of downtime over 30 days. We calculate our SLOs over rolling periods of 30 days. For 4 nines, for example, we would only have a budget of about 4.5 minutes before we breach the SLO. So the good thing we see here is that we have got 69% of error budget left. That is 69% of the 21 minutes left in the tank that we can use up to push out new features. If the SLO is breached and our charts are red, this would give SRE a very strong signal that we need to slow down the feature velocity and focus more on improving the system stability. Good. Now that we have all our SLIs and SLOs in place, we can sit back and bask in the glory of our fabulous charts because we can see all our happy customers, right? Not quite. The Neo4j operator is constantly looking for and healing unhealthy databases, and the SLRs show us how well it's doing it. Sometimes the unexpected can happen and we need to get some humans involved. So now we need to talk about alerting. We have already talked a bit about alerting thresholds and percentiles and high quality signals, but why don't we just alert on everything? Well, firstly, people don't like to get alerted. When there are too many alerts going on, people start suffering from alert fatigue, which means that alerts start getting ignored and worse, more important alerts can be missed because they are being drowned out by frequent low priority alerts. At Aura, we break down our alerts into 3 categories to help cope with this. First, we have records. These are low-level alerts, such as errors in logs or short-lived spikes in the metrics, basically things we will create a ticket for, mute the alert, schedule the investigation along with other work items. Next, we have our alert notifications. These are more important alerts, but not super critical. For example, a database whose last backup is 4 hours too stale. Yes, this is important, but we can leave that till next morning. And finally, our pages. These are super critical, stop what you're doing type alerts. They require immediate attention. Widespread database unavailability or malfunctioning Neo4j operators fall into this category because they are signals that the system is now seriously degraded. But where do these alerts go? We still need to get the humans involved. Alert records go to error reporting software where similar errors can be grouped together and, more importantly, so that we can mute that alert so that more errors of the same type don't carry on alerting us. Notifications go to the day shift team. This is the SRE team that's working the usual business hours. Alerts that are first sent to Slack channels, and if they aren't acknowledged within a certain amount of time, they will get promoted to pages. And of course, the pages themselves. Pages which fire off during the working day go to the same day shift SRE team I just mentioned, but at night, they go to the on-call engineer. So now hang on, we need an on-call team. Yep, in order to achieve happy customers, we need to respond to pages around the clock, day and night. But the SRE team is based in Europe and not working 24/7. So we need an on-call rotation in place so that pages at midnight or at the weekend can also be responded to. Our on-call engineers are all hooked up to our alerting system, and they can set up their own preferences as how they would like to be alerted. Some prefer push notifications to their watches, while others rely on noisy landlines like we see here in the image. As part of the page lifecycle, our responders can set up a range of notifications. So maybe you want to be notified immediately via a push notification, then after 5 minutes a text message, and after 7 minutes a phone call. It's all very flexible. In fact, my wife's phone number is my 7-minute escalation, which thankfully has never been needed. So what happens when you get paged? Okay, well, it's 3 o'clock in the morning. You've just been paged and you're looking at the notification blurry-eyed. The last thing you want to ask yourself is, what does this mean? Pages need to be very clear when they reach our responders. They will mention clearly and exactly what the SLO breach is and for how long the condition has been triggering. Once the responder knows which SLO breach they've been paged for, they are able to pull up the appropriate playbook and start working on the incident. But what is a playbook and where do they come from? Well, no one can go on call without the required training. At Aura, it's not only SREs that staff the on-call rotation, but other members from the engineering team as well. To accomplish this, the SRE team have created an on-call syllabus to make sure people who go on call are prepared to handle incidents. During the training, engineers are given an overview of all the playbooks, detailed background information about each playbook, as well as the context of when those playbooks should be used. And of course, we provide the commands and tooling so that our trainees have the ability to run the playbooks for themselves in their own environments. In addition, we also require on-call engineers to work on the SRE day shift team for a few weeks. Here they will get the opportunity to handle real live incidents, but with the knowledge that other engineers are nearby to help out if needed. But as we know, documents and playbooks get out of date, dashboards will change over time, and people forget what they've learned, especially true if you've been on call for a while, but not needed to respond to an incident. So the SRE team also hosts frequent fire drill days. On these days, we create special environments with all the active alerts and dedicated Slack channels that exactly the same as you would find in production. This is a safe place where responders can practice their SRE skills by declaring incidents, running through playbooks, and getting reacquainted with new dashboards and useful metrics. Some engineers will have the role of responder, while others will be in charge of injecting chaos into the system, all the while monitoring the response in the various incident channels. Not only are these fire drills good for our responders training, but it's also good at weeding out areas or gaps in our playbooks. This is important because when the page goes off and you're on call, we really don't want to see this. Probably one of Johannes' favorite slides, but it's also true. We really want to avoid adding extra stress to the situation. For instance, imagine an unprepared on-call engineer making a disastrous change, which makes things much, much worse. But we don't just have fire drill days. SRE also host game days. The distinction between the two is that on fire drill days, we practice what we should know. On game days, we get to explore the unknown. Maybe a new vulnerability has been discovered, which will lead to a game day with a security focus. Or could it be that we've added new components to the system and we aren't yet sure what the blast radius looks like when they break? If nothing else, it's a great opportunity to throw everything you've got at the system and see what happens. Maybe it recovers by itself. Maybe it needs manual intervention, and which will lead to a great opportunity for another playbook. Good. Now we've covered all the most important parts of how SRE thinks and delivers our incident response. And pulling all these pieces together, we're able to have happy customers. But is on-call training all the responder needs to be able to have a peaceful night's sleep, even when they're on call? After all, we know the Neo4j operators working tirelessly around the clock to do the heavy lifting in terms of healing and taking backups. But how do we know it's actually very good at its job? We need more chaos. The Aura environment is already a pretty hostile place. Software and features are constantly being dark launched. Customers are creating and resizing the databases around the clock, and this in turn causes new infrastructure to be provisioned on the fly. But for some extra reassurance to our on-call engineers, we'll also run chaos monkeys in all environments, including production. The chaos monkeys have a number of tricks up their sleeves. They're able to forcefully terminate running processes, including the database JVMs and the Neo4j operators. They cause database pods to get restarted, and they're constantly on the lookout for nodes to drain, thus evicting all the workloads to simulate a node failure. The chaos monkeys have taught us a great deal about our system, and we have flushed out countless bugs and weak areas in both the Aura architecture as well as the Neo4j core product. And we love running them and embrace the chaos they inflict. And on that note, I think this is a great place to stop and take a breath, and so I'll hand back to Johannes.
Thank you, Julien. That was a really a good explanation through some of the aspects of SRE at Neo4j Aura. However, I think there was so much we could talk about. For example, you mentioned that we have like different environments. So you said that every engineer have its own environment, basically a copy of the production Aura system. And in order to achieve that, you're doing a great job in keeping all the needed tooling in place for us to create those environments and use those environments. As well, all the automation around deployments, getting like code actually shipped out through all the stages, going from the developer environment to the pre-staging, to the staging, to the production environment, and doing all that kind of stuff, alongside with your daily checks, where you go over the past day and see what happens if all the dashboards that you mentioned earlier are still looking good, if we had some outliers or some peaks in one of the graphs. And also always with the aim to reduce toil. So this is another fancy term in the SRE world, which is toil. This is basically effort that we need to do, or items on the work items we need to do that don't add benefit to or value to the product. And an example for such toil is a manually clean up after something. So whenever this happens, I know you're doing a great effort in putting some automation in place so that you don't need to do the same cleanup again. And maybe a last highlight I want to give is the elastic scaling that we're doing. So since we're running on Kubernetes and we're running on managed Kubernetes, we can take advantage of some of the auto scaling facilities that comes with it. So when we reach capacity in one of our clusters, we would not go in manually and rescale the clusters to add more servers to it. This will be done by the cloud vendors for us. And this is also going the other direction. So it's not always growing. Sometimes there are some shrinkings in the service as well. But then you really need to make sure that you're not doing too many downsizes at once. So imagine the autoscaler detects that you want to get rid of 3 servers, but for a bad coincidence, those 3 servers would host exactly the 3 nodes of your Neo4j cluster. So that would be very unfortunate because we would lose service for that specific database. And there's like a lot of tooling around that, how you can prevent the autoscaler from making bad decisions, basically. Okay, but looking at the time, I think it's time to wrap up and go over to the questions from the audience. So let's see what we got here. We got the first question. I think this is one for you, Julien. How do you decide what you get paged on and when do you get paged on?
Yeah, that's a great question. And the answer is mostly a bit of trial and error. We recognized early on that we didn't want to get paged for single isolated incidents because, like I said before, we're alerting at scale. So we've got hundreds of databases, thousands of pods, and we need to rely on our percentiles to be able to throttle the amount of alerts coming in. We wanted to be paged only for the most serious ones, and the different levels that we talked about in the SLIs allows us to set different thresholds. So for instance, a P99, which means 1% of databases unavailable, could trigger after half an hour, while a P75, which means 25% of our databases are unavailable, will trigger after 5 minutes. And this is useful for us because this allows the operator to have an opportunity to try and heal the system, so we don't have to bother somebody at 3 o'clock in the morning. Often that's enough because the operator might get stuck on something, and then because it's working on in a distributed world, something that might get unblocked, and then later it'll be able to auto repair the system. Does that answer your question?
I think so. If I would add a more refined version, so I think it's a fine balance of finding the right moment when to alert, especially like you said, when you want to give the operator enough time to heal itself, but at one point you need to make the cut and say, okay, we watched that for a couple of minutes and we don't think the operator can get out of that stuckness on its own. So we need to have some manual escalation and manual resolving of the problem. Okay. We got another one here. I think it's kind of related. So how many times have you been paged and what was the reason?
Yeah. I've been paged once, and the reason was that a certain amount of backups appear to be stale. Unfortunately, there was a false alarm in my case. The problem wasn't actually with the backups themselves; it was with the reporting agent had been partitioned from the system and couldn't see what the latest backups were. And so I got paged falsely. But as an output for that, we, as part of the postmortems for incidents, we always review the type of things that we get paged for. And in this instance, we decided that the SRE team being paged for backups doesn't make a great deal of sense because we're taking backups every 24 hours. So to notice that something's gone stale and wake somebody up in the middle of the night has a long time frame and typically can wait for business hours. So we could refine our metrics or our pages to only trigger for the most important items.
That makes sense, especially when you're looking at we guarantee to have a backup on every day. There's no need to have it in the middle of the night when you have this opportunity to resolve the problem during daytime. But there was another thing that you just mentioned, which was the postmortems, which is, I guess, very interesting. So after we got a page or an incident, we analyze what we're doing, and then we take actions like you just said. That we don't want to be alerted on stale backups anymore. So this is also, I guess, some in the SRE manifesto, or in a really big institute, that you review the things that happened in a blameless postmortem and then take actions from what you've actually learned during that incident.
Yeah, so we find those very useful because it gives us the opportunity to reflect on why the page went off, what we could have done to mitigate it. Do we need to build extra controls into the system? Do we need to have more healing available, or did we actually find a genuine bug in the latest version of Neo4j? And so in the postmortem, we will typically create a bunch of cards and tickets and work items for either ourselves as SRE or the orchestration team, or for the product itself to patch the gaps. And the other thing that is really great about a postmortem is if you've identified an issue, we can actually say, we call it a known issue. And so further occurrences of the same issue, we don't have to investigate fully because we've already got a playbook for it.
Yeah, so to make the next person being on call and paged lives easier by having a prepared set of instructions how to resolve the problem. Okay, okay, so you've been paged once, and so I've never been paged so far. So I'm going on call in 2 days. So maybe that might be changing in the future. But so far, I wasn't been paged. And I think we're doing the on-call rotation and nightly shifts for about 12, 13 months or something. Is that correct?
Yeah, that's right. So Aura launched about in November last year, and we started on call about a month or two before to start practicing. Mm-hmm. And since then, I think we've had 7 pages or so. So it is quite a rare event. Most of these pages have actually been around the operators. So the operator, as mentioned earlier, not only do they do the auto healing, taking backups, but they also are eyes and ears of the system. They're doing the measurements for us. And so if the operator stops working, we are flying blind. So that is one of the more critical pages that we would get. Unfortunately, they are very susceptible to network outages. Of course, they're doing requests to the databases, they're looking at the endpoints, they're trying to form a view of what the cluster health is. And if any of those network connections can't be made, it can't update the status of the database, and so we'll trigger a page. Typically, they do very well. All the databases are kept up to date on about a minute interval, but after 5 minutes or so, we'd actually page if the operator's not getting around and doing its work.
Okay. I think this, sorry for me adding some things to the questions, but I think we covered the second question quite good. So let's pick a third one. Okay, can you explain a little bit more about your build automation and how you safely release software to production?
Yes, great question. So SRE at Aura is actually also the release team. So we are in charge of the release pipelines. And we have multiple stages to the pipeline. We have a continuous integration system that continuously deploys the latest fixes into something called pre-staging. So those are fixes that are drip fed into that system, and engineers can troubleshoot their features there if they require. And then we have release days where we would bundle all those fixes together and ship them off to staging as a set. This allows us to, you know, if we had to roll something back, we can test in staging whether we can roll the whole set back. And then finally, we release everything to production. And I'm using terms here like release and deploy. So we deploy the software to the system, and later on we will release the software. So we really don't want to update all our databases at exactly the same time. For example, to upgrade one database, which has three nodes, we need to scale up to 5 nodes and then scale back down to 3. This is to allow us to keep the fault tolerance while we're doing the upgrade. But we've also got protections in place so that no 2 instances of the same database runs on the same node, anti-affinity rules. And so each database will all of a sudden take up 5 nodes. So if we did that to all of our databases at the same time, the autoscaler would horizontally scale out the nodes super wide. And by the time we finished, we would have a lot of instability as the autoscaler scales down the nodes to fit the databases back onto the resources we need at steady state. So we do the releases to the databases in a canary fashion. We've got sort of two levers to pull. One is by database priority. So the internal users and our canary databases, which are simulated user databases, always get transferred first, and the priority increases depending on you know, whether it's paying customers and so on. But we have lots of those as well. So we also throttle the amount of databases transferring at once. So we're protecting the operator from trying to do too much work. And so we kind of drip feed, as it progresses through databases, we drip feed in new ones at the priority level. And it will actually stop and wait for all the databases at its priority, at the given priority to be transferred before it goes on to the next step. So if we do have a bug in our software somewhere, the release will actually stop, hopefully before it reaches customer databases.
Yeah, so this is because we start with the lowest priority first with the internal databases and see if the new version of the operator can pick it up and roll the new version in successfully. So we would test on our canary databases and our internal testing databases before the new version, even though it reached all the way towards production, we would have the last safety net that we test on all our internal database first before we would dare to touch our customer databases. Cool. One thing that popped to my mind that I really enjoy doing, and I think this is also a great part towards stability in that process, is when we're doing these release days that you talked about, where we're packaging all the commits that went to pre-staging. You will be invited, if you have a PR that got merged and is part of that release train, you will be invited to a private channel and you will be asked to verify that your changes that you made in the PR are working on staging. So I really like that because it gives me another level of trust in my change. So even though I wrote tests, I tested in my environment, it is running on pre-staging for quite some time. I go in and manually verify that my changes are working on staging. And I guess we had quite some occasions where, for whatever reason, it sneaked through that process and we found like a bad commit, a bad PR in staging. So we had the opportunity to roll it back, basically. So I really enjoy that. I hope you also quite like that, a kind of security net while doing releases.
Yeah, so that's a great point. So, like I said, the SREs are in charge of the pipelines, but we really do want to have a shared fate between all the Aura engineers. So, if something goes wrong, it's not, the burden isn't totally on the SRE team. And so, having everybody in the release channel, like you've mentioned already, we've got automated tooling to do health checks on the environment. So we run a script and we get a score back, see if there's any new errors. We see if there's metrics failing. We will see if the release has failed for some reason. And everybody in that private channel can work together as a release team to figure out what the problem is and whether we should call off the release. So that's a great feature of how we work at Aura.
Cool. I guess we got a lot of the questions covered. So if you have any more questions, please feel free to ping us on Twitter. So Julien is not on Twitter, but you can ask me or mention Neo4j in your message and in your question. And I will make sure that your question will reach Julien, and then we will come back to you to answer all the questions that may or may not have come up through this presentation. And in that case, I wish you a wonderful Node conference. Enjoy all the other presentations, and have a wonderful day. Bye-bye.